Hello, how's it going? Welcome to day 2. We're gonna do some more Advent of Code today. Yesterday was a disaster. I used list.folldel. It was very stupid. I made a dev2 article. I'm gonna have to share this at some point. Going over what programming Elm. I just posted it. There we go. I made this article. I'm gonna include it in the link to the description below. This is an alternative solution that doesn't involve list.folldel that I came up with immediately after recording the video yesterday. So my name's Ryan. If you didn't watch the last video, what we're doing is every day for as long as I can manage, we're going to be doing Advent of Code problems. So yesterday was day 1. Today is day 2. I haven't looked at the problem yet. And we're doing all of them in this language called Elm. There's this article on how to do yesterday's problem. There's also a video probably linked somewhere near my face. But what we're going to do today is we're going to dive into day 2 and see how it goes. So let's get started. I've got that in the thing. We've got kind of a new blank canvas here that's just printing out question marks for now. Let's figure out what today's problem is all about. Rock, paper, scissors. Elves began to set up camp on the beach to decide whose tent gets to be closest to the snack storage. A giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between 2 players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using a hand shape. Then a winner for that round is selected. Rock defeats scissors, scissors defeats paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, which is our puzzle input, that they will say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, and C for scissors. The second column, suddenly the elf is called away to help with someone's tent. The second column, you reason, must be what you should play in response. X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is a score for the shape you selected. 1 for rock, 2 for paper, and 3 for scissors, plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were given the following strategy guide. So here's our little puzzle input. A, Y, B, X, C, Z. So it's saying in the first round with this A, Y, opponent chooses rock, I choose paper. That means I win. So I get 2 points for choosing paper. What does it say? I got 2 points for choosing paper, and then 6 points for winning, for a total of 8 points. Second round, your opponent will choose paper, and you should choose rock. This ends in a loss for you with a score of 1, because I chose rock, which was worth 1, and because I lost, which is worth 0. Cool. The third round is a draw with both players choosing scissors, giving you a score of 3 plus 3. This example, if you were to follow the strategy guide, you would get a total score of 15. What would your total score be if everything goes exactly according to your strategy guide? Okay, so how these problems work is they'll give us this input, they'll give us an example, and they'll give us an answer. So this is like a kind of a small data set here. And so how I start these is I start with the input. We've got this little program here. This is kind of like CodePen for Elm. This is Ellie. We're going to be doing everything in here, and then I'm going to be sharing links. So like the URL for the answer to this puzzle will be in the description below, so you can check it out at the end of the video. But let's dive in and try to turn this into something where we can figure out what our score is. So the first thing I see is I need to break this into, break up these, this single string separated by this new line character into lines. So using the string.lines function that we used yesterday, we can do that. And then what I want to do is I think for each round, I want to convert like the A's and the Y's and the B's and the X's into like moves that the player did. So I'm going to say list.filterMap. So this is going to discard invalid. Filter map is going to discard like invalid states. and I'm going to say two, I'm going to call it two round summaries. This is just a summary of what happened in that round. So I'm going to get a string as input, and then as output, I'm going to maybe get back what my opponent did. So rock, paper, scissors, I guess I'll just call that a hand. I don't know what that is. And then for what I did, opponent, and then player will be us. Maybe I'll just call us and them. Them. So this is going to take in a string, and this could be any string. So what we're going to have to do is we're going to have to split on spaces. And what that hopefully will do is, hopefully it won't give us an empty list. If it does, if there's no options here, then we'll do nothing. If it only gives us one item, so if it gives us this, that's also not valid. What we're expecting is we're expecting a letter. So this is the opponent's letter. And we're expecting our letter. And nothing else. So hopefully this works out. And then what we can do is we can say them equals from letter to hand, and we'll give the opponent's letter. So all I'm going to do is pretend that there's a function called from letter to hand, which will convert a string to we'll convert a string to something called a hand. So we haven't defined a hand yet. So a hand could either be rock or paper or scissors. So if we wanted to make a function here, just make a bunch of new lines, add some of these so that format doesn't totally delete all my white space at the bottom of the file. From letter to hand, string, and then maybe we can turn a string into, maybe we can turn it into a hand. Maybe that works, maybe it doesn't. So what we're going to see is, whatever the letter is A, we're going to turn A into rock. We're going to turn B into paper and C into scissors. So let's do that real quick. A is going to be rock. Say just rock. You'll see the reason for the maybe in a bit, because there's other letters that aren't valid, like D, E, F, or any other string that we get. Paper. C is going to be just scissors. Same with X, Y, and Z. So copy this. And for everything else, we're going to say that's not valid. It's not a valid hand. So nothing is Elm's way of representing null, and that's what we're going to be using to track like values that didn't convert okay. So this is going to give us a maybe hand. So if I compile this right now, I think we're going to get an error, which is saying that, yeah, them is getting a maybe hand on this line, but we're expecting to always have a hand. So there's a cool trick where we can use this function called maybe.map2. And what this does is this could take them and take us. Oops, I called it use. That's also a bug. Them equals them, us equals us. And what we can do is we can kind of run both of these, and then hopefully give us something else. Oh yeah, and then if we have anything else, that's also going to be nothing. So if we have more than 3 letters in our puzzle, that's no good. Okay, this is great. So let's just format this real quick. So this is a little Elm format button. Elm's got a built-in like formatter that the community uses that makes it so we don't have to worry about getting all the indentation right. So you'll see me using that in my videos. Just clicking this little format button in the top right. So what we did so far was we took this puzzle input. So A and Y says rock and paper. B and X is paper and then rock. And then C and Z should be scissors and scissors. So it looks like we're doing the parsing right. And we're dealing with these, this is called a custom type in Elm. So this is the custom type hand, and then these are all the custom like variants or the custom values that we can make. So hand is either rock, paper, or scissors. It can't be anything else. It can't be like null or undefined or a string or anything. It's only ever these values. So we use this a lot in Elm to kind of model like the states of our app that we want to keep track of. So for example, a Boolean would be true or false. A hand is rock, paper, or scissors. Cool. So we have that, and now what we need to do is we need to kind of like see if we won or if we lost. So let's have a function that for each round, so these are all valid rounds, we'll say list.map to score for round. So we're going to make another function. And I didn't give this a name, so I'd either have to copy paste this type, or what I can do is I can make something called a type alias. So in Elm, you can make a type alias. It's a little bit different than a type. It's basically just a nickname for an existing shape. So this record is an existing type that I have. What this can do is it can replace these. And so the code will still work the same. It's just now I've got a convenient word that I can use when I'm building these functions. So if I have a round summary, I've got the them and I've got the us. I can say we've got the points for my choice. So this is what we saw in the beginning of the puzzle. So when we saw that if I choose rock, I get 1 point. If I choose paper, I get 2, and scissors, I get 3. This part of the equation is going to account for that. So in the case where my choice was rock, I'll get 1 point. And then in the case where it's paper, I'll get 2. And in the case where it's scissors, I'll get 3. So that's the points for my choice. So that's not the full story. So this is only accounting for just the points I would get for making a choice. We also need to figure out the result. Points from result. This is also an integer. And this one depends on 2 things, not just my choice, but also my opponent's choice. So if my opponent chooses rock and I choose rock, then that's a draw. So it's said that draw is worth 3, and win is worth 6, and a tie is worth 0. So all the draws are worth 3, so let's just get those cases taken care of. So if we ever choose the same thing, this is a thing in Elm called pattern matching. We can kind of go through all the possible cases, and Elm's got our back. So if I compile this, it's going to tell me about all the cases that I need to handle, which is really nice. It's kind of like a switch case, but we get this kind of like exhaustive branch handling. And the Elm compiler gives us really nice messages to tell us what we need to fill in. So if the opponent did rock and I do paper, I win. If the opponent did rock and I did scissors, I lose. If the opponent did paper and I did rock, I lose. If the opponent did paper and I did scissors, then I win. If they did scissors and I did rock, then I'm going to win. And if they did scissors and I did paper, I'm going to lose. So we should have 3 3s, we should have 3 6s, and 3 0s. That's how we know that it's that I didn't screw that up. So if we take points for my choice and we add that to points from the result of the round, we're going to get 8, 1, and 6. And I think if we look here, those are the numbers we get. And so now all we have to do is just sum those up. So if I've got a list of numbers and I want to add them up, Elm has a built-in a function for that. So right after this, call this .sum. And hopefully that gives me 15. Great. So I'm going to do some little kind of comments here to help you understand like what this pipeline is doing and how the values are transforming over time. So when we got our puzzle input, if you remember, that was a string. So that's down here. Puzzle input, the type of this is string. So everything we did in the pipeline kind of transformed the value, and sometimes it changed what the type was here too. So what we're going to see is when I called string.lines, it wasn't a string anymore, it was the list of strings. And then after I called filter map with to round summary, I ended up with a list of these round summary things. So this filtered out any invalid strings. So for example, if like there was a typo in my puzzle input, my program's not going to crash. So if this was D, it would just not include the first round. So we'd probably get, I think, 7 for this because that 8-point round wouldn't count. So there you go. So Elm doesn't crash and it doesn't throw exceptions or anything like that. So we need to make sure that we handle all those cases. And so that's what filter map's doing for us. And then to score from round, this is going to be a list of integers. And then finally, when we take the list of integers and we call sum on that list, we get a total at the end. So this looks good. I'm going to save this. I'm going to copy this link so I make sure that I remember to put it in the video description. So that is part 1. Got a little notepad on the side here. Great. And let's try it out with our puzzle input. So my puzzle input is going to be different than yours, but it's basically just going to be a huge input like this. And we're going to see if our program holds up, if it works for this complicated thing. So if I compile this, looks like my answer is 14,375. So let's see if it works. Hooray! All right, we got a gold star. So feeling pretty good. Awesome. So I'm going to go into the settings here. This is going to be, I'm going to undo this, go back to my simple result. And I'm just going to make sure I name this so that the little label at the top when I share the link is part 2. So this should get me back to 15. Awesome. Okay, I'm going to save that. Okay, great. So all of these puzzles, how they work is you have kind of part 1, which is easy, and then part 2 builds on the code that we wrote before. So let's see what we have to do. My guess is that we misunderstood what XYZ was. That's my vibe based on the exposition here, or whatever that is for the story. The elf finishes helping with the 10 and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. The total score is still calculated the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example above goes down like this. In the first round, your opponent will choose rock, A. So we have this same input from before, AY, BX, CZ. So if they choose A, I need to get a draw, which is Y. So that means I need to choose rock. And so this gives us a score of rock plus draw, which is 4. The second round, they choose paper, and I need to lose, so I have to choose rock. And that gives me 1. In the third round, you will defeat your opponent's scissors with rock for a score of 1 plus 6 equals 7. Now that you're correctly decrypting the ultra top secret strategy guide, you get a total score of 12. So we need to modify our code to kind of change how we interpret the input. So let's kind of go back to our steps here. So I'm just going to comment out the stuff we did before, and we'll go right back to kind of where we were. So here, this is to round summary. And in part 1, we interpreted each letter. So we have this from letter to hand function. And what this did is it said, okay, if it's A and it's B and it's C, then I need to map to these things. X, Y, and Z map to these things always. But the challenge here is I'm going to need to know, based on what they chose, what I'm supposed to do. So what I think I want to do is I'm going to make a copy of this function here. I'm going to get rid of this, and I'm going to do some renames. So from opponent letter to hand. So this is going to calculate my opponent's hand. And then what I'm going to hope for here is that I already have an opponent's hand. So whatever they choose, I'm going to need to make my choice based off that. So we have this. And then what I need to do is if I have an X, I need to look at the opponent's hand to figure out what to use. So in the case where the opponent's hand is rock, so there's rock, there's paper, there's scissors. I need to choose a choice for each of these. So I'm just going to kind of put these in here for now. So just something, and I'm just going to copy these. And we're going to have this determine what our choice is. So if I pick X, the puzzle said that X means I need to lose. So if I need to lose and they choose rock, then the way I lose is I choose scissors. If I need to lose and they pick paper, I need to pick rock. If I need to lose and they pick scissors, I need to pick paper. So that's good. All right, so Y I think was draw. Let me just confirm. Y means I need to end the round in a draw. Okay, great. Oops. So if they pick rock, I pick rock. If they pick paper, I pick paper. If they pick scissors, I pick scissors. And then finally, if I need to win, the way I beat rock is with paper, the way I beat paper is with scissors, and the way I beat scissors is with rock. And then if there's any other letter that I get, that's no good. So this is from my letter. So if I compile this, Elm's going to let me know what I'm missing out on. So I'm going to hit format here, hit compile, and it's going to be like, yo, what is this from letter to hand thing? And that's going to remind me to come up here and to update my code. So what we're going to start with is we are going to start with the opponent's hand. We're going to kind of grab that here. This is going to be a maybe hand. What we're going to do is we're only going to be able to calculate the second thing. So this returns a maybe hand. And then if the opponent's hand is valid, so if it was an A, a B, or a C, we can kind of continue running our program. So if I did get a hand for the opponent, what I need to do is I need to basically, I can do a maybe.map here. I'm just going to do a nested case expression. I think it'll be easier to read. So from, or easier to follow, maybe not easier to read. From my letter to hand, I will pass in the opponent's hand. So I guess this is more of a maybe. Oops. Maybe this. This isn't a hand, this is a maybe hand. So maybe opponent hand. This is my opponent's hand. So if they have a valid hand, I'm going to pass that in, and then I'm going to pass in a letter. And if I actually end up getting a valid hand here, what we can do is we can return what we expected. Plus equals, and then our hand. Sorry for all this code down here. All right, so in the case that we can't figure out what our hand is supposed to be, it means that this isn't a valid round, so we're going to return nothing. And then similarly, there is this nothing branch. There's a clever Elm way to write this. I can use these functions, maybe map, maybe and then. I'm not going to get into that. Maybe I'll show you at the end of the video how to do that. But in my experience, it's a little bit easier for folks to follow. So I like to do it that way. Okay, great. So I have this. I have 2 round summary. So all these comments got formatted inside of here. So when I do this, I should still end up with a list of round summaries. So let's make sure that this matches up with what the puzzle was saying. So in the first example, they choose rock, and I'm supposed to choose rock. Rock and rock. Great. The second example, they choose paper, so I'm supposed to choose rock. Paper and rock. Awesome. And then they choose scissors, so I'm supposed to choose rock. It looks like I'm choosing rock every time. Scissors and rock. Okay, great. And the rest of the, now that my choices are right, I think the rest of our code is totally spot on. And we end up with 12, right? So the way we compute scores is still the same. The only thing that changed was how I calculate my round summary. So it's really like this function changed here, and then kind of the functions that I use here changed. So now X, Y, and Z are based on what my opponent picked. So I think that's correct. So I'm going to just add these back in. So we get those again. So we started with a string, we turn that to a list of strings, we turn that to a list of kind of round summaries. I could have just called these list of rounds probably. Why not? Why not rename that? Refactoring Elm is easy. If I make a change in one spot, it's going to tell me all the problems that I have. So for example, I need to change this one, because my types don't match. And as soon as it compiles, the rename worked. Cool. So I've got 12. Save this. I'm going to copy that link. I think hopefully, hopefully this will work for us. And get our puzzle input again. I think it's the same input, but I'm just going to do it. We are going to put in our puzzle input at the bottom here. Run it, and I get 10, 2, 7, 4. Sick. All right, we're 2 days down. We got 4 stars. Life's easy. Let's take a look at the code, and I'm going to show you that cool trendy person trick. So you might see some advanced Elm developers using functions like maybe map and maybe and then to prevent kind of like this nested case thing. A lot of people like me have experience with like callback hell in JavaScript, if you're familiar with that term, where things get like super indented. So people like to keep things flat. So this code here, I'm gonna just put in a big comment block, and I'm gonna rewrite it using some maybe functions that come from Elm's core library. So everything that we did in this whole thing, every Elm thing is fully documented, and there's all these functions. There's this map function here. There's this and then function. And so if you ever are curious about things, I'm going to copy a link to the docs. The last video should have also had this, but for like helpful links, there'll be a helpful links section in this description, and that's going to include a link to these docs. But let's rewrite this using like the trendy Elm developer way to do it. So we're going to start with an opponent letter. We're going to pipe that into from opponent hand. So I'm going to do the exact same thing I did above to try to help you follow like what these types are. So here I've got a string, right? So opponent letter is the first letter, and then when I run this, I'm going to have a maybe hand. And so if I have a maybe, I want to also return a maybe. I'm going to use this function called maybe and then. And how maybe and then is going to work is this is going to be to maybe round. So to maybe round, I need it to return this, but my input is this. So what this is going to do is this is going to take this maybe hand, which is the opponent's hand, and it's going to return a maybe round. So this is our maybe opponent hand. There's an even more trendy way to do this that I really don't want to do, but I might just do it for funsies. It's not my style. I like to make my code as easy to scan as possible. So you'll see I usually go for case expressions like this when I can, and try to avoid these kind of like cool functions. Anyway, so I've got this maybe opponent hand. What I need to do is I need to get the player's hand. So this is going to be the player's hand. So this is our hand, I guess. So what we're going to do is we're going to take the opponent's hand. We're going to maybe map that. We're going to maybe and then that again. This is why I didn't do it this way in the first place, because it's crazy. We're going to maybe and then this. And I guess I could do it all in line. That's kind of the spirit of these weird chaining things, is trying to make it as confusing as possible. Maybe hand. And then what I'm left with is a maybe map of, it's like one of these things. So it's that thing we had from before where you have the them and the us, and then you make a record of them, and you make a record of us, and then you do this, but then you take the please don't write code like this, and then you take the function here that needs one of these, and then you take your letter, and that'll give you a maybe, and then if your maybe's okay, and you know that they have an opponent's hand, then you can put this here, and that goes there, and then I think this is a maybe round, and Elm will tell me if I'm wrong. I am wrong. Maybe and then maybe map. Maybe and then the maybe. This is an and then. I get the thing. This gives me a maybe. This should not give me a maybe. What am I messing up here? So from opponent letter to hand gives me a maybe hand. This gives me a maybe round. That's a hand. Right? Oh yeah, that's right. This is already a hand. So all the stuff I did here is a lot simpler. Sorry, I screwed that up. Okay. Okay. So all that was the same way of doing this. So we start with a string. We turn it into a maybe hand by doing this. Maybe and then allows me to only handle the case where it worked. That was the part that I messed up there. So if you look at the lines of code, what I wrote here, it's 32 to 40, so that's 8 lines of code. Compare that with 43 to 61, that's about 20 lines of code, a little bit under that, 18. So there's 10 extra lines of code, but there's all these kind of new concepts that get involved here. And there's like a lambda going on, and we're doing all kinds of crazy stuff. So it's been my experience. When I first started doing Elm, I wrote a lot of code like this. And then as I started working on teams, I started being a big dummy. So this is another way to write it. I can save this. This is kind of fancy if you guys want to see that solution and play around with it yourself. This is kind of like the functional programmer way, but I'm not a functional programmer. I'm just a person that uses Elm. Just a regular dude. Cool. So yeah, in my experience, I much prefer writing it this way because I think it's a lot easier to read. If you're not familiar with Elm, it's a lot easier for you to kind of follow the branches and understand in what cases we get values and in what cases we return nothing. So I'm very happy with this. And it gives us the same answer. Okay, well, that was it. I had to add some stuff at the end there because we did it too fast. But I hope to see you next time for part 3. Be sure to check out the last video if you haven't. And then I post these things on Twitter. Oh, and if you want to read a simpler solution for yesterday's problem, you should check that out. Yeah, that's it for me. I'll catch you guys later. Goodbye.